Most developers think performance is about being clever, smart abstractions, elegant patterns, and expressive code. But the machine doesn't see cleverness. It only sees instructions, memory reads, branches, and cache misses. Performance bugs don't come from advanced ideas. They come from fundamentals executed poorly, thousands or millions of times. We're going to look at why memory access, predictability, and hardware thinking matter more than clever code, and why mastering the basics beats every optimization trick you'll ever learn. This loop looks harmless, but its performance is dominated by one thing: memory access. The CPU can execute arithmetic incredibly fast, but waiting for memory can stall execution for hundreds of cycles. If data is laid out contiguously, this loop screams. If it's scattered across memory, it crawls. The CPU isn't struggling with math. It's waiting. When people say the CPU is slow, they usually mean the CPU is waiting on memory. Branches look innocent, but they're expensive when unpredictable. Modern CPUs guess which branch will run next. When they guess right, executions stay fast. When they guess wrong, the CPU throws work away and starts over. Clever branching logic often destroys predictability. Simple, boring, consistent logic wins because the CPU can learn it. Performance loves repetition. It hates surprises. Abstractions feel clean because they remove visible complexity, but they also remove visibility into execution. That call might allocate memory, jump across modules, miss caches, or branch unpredictably, and you wouldn't know by reading the loop. The hardware still pays every cost. When performance matters, hidden work becomes dangerous. This doesn't mean never abstract. It means understand what your abstractions actually do at runtime. Hardware thinking means asking different questions, not is this elegant, but what does this execute into? How many loads? How many branches? How often does it jump? Performance improves when you reason in terms of execution steps instead of concepts. The CPU never asks why your loop exists. It just runs instructions over and over at brutal speed. Most performance bugs hide in the most basic structures: loops, conditionals, and memory access. These constantly run. A tiny inefficiency here gets multiplied millions of times. Fancy tricks might win benchmarks, but fundamentals win production systems. If your execution path is clean, predictable, and memory-friendly, the compiler and hardware can help you. If it's chaotic, nothing can save it. You don't optimize your way into good performance, you design your way there. Mastering fundamentals means writing code that flows cleanly through hardware by default. Simple loops, predictable branches, conscious memory access. When those are solid, optimization becomes easy and often unnecessary. When they aren't, not even a profiler will save you.